informations we have to know. That's only we are getting the method. So here from simple attack is a molecular node. So here from the multiple entries you have to project it one person with a different name. So like this I'm putting as a of 3, 2. But here sending the message of A of 3, 2, A of A1 of 2, 3, A of 2, 1, A of 1, 2. So one person at as a different machines. That type of category we can call as a methods. So lightweight algorithm, lightweight encryption algorithm only we have to prefer. So WSN, we have to standalone security protocol. We have used the secure network encryption protocol and the certain section security also we have to work. So here we can call this one important thing from that Tesla from the micro, not a Tesla company. It is called as micro timed efficient streaming technique we are using with that WSN wireless sensor networks. So here from that any security we have used with the authentication encryption. Authentication we have to focus from 2 different categories. So here some comparison I put it the protocols we are used relevant attacks. Either it may be on energy conversion topology or clustering, leads or TIN or minimum cost forecasting or geographic routing. So these are the categories we have to link with the. So here link layer security we are using with simple link layer encryption and authentications. We are using the SAD key technique. So that type of techniques we have to avoid with that Sybil select to forwarding single, the type of we had to reduce, and also link layer security mechanisms. So protections of hollow flood or worm call also we had to secure. So routing will be a geographical protocol that considers the topology on demand of using locations node interactions inside of the base stations we had to secure. So here are the security solutions for the most common issues. So one from the security, the IoT networks. So security IoT networks to protect and secure the network connecting IoT devices to the backend system on the internet by implementing the endpoint security features such as antivirus, firewall, or intrusion preventions, or IDS, intrusion detection system, or anti-malware. This type of like we have to secure the IoT networks. The second category of authenticate the IoT devices. It allows the user to authenticate the IoT devices by introducing the multiple user management features for a single IoT devices and implementing the robust authentication mechanisms such as two-factor authentications, digital certificate, and biometrics. These are the things we must include it. So our IoT devices must be authenticated. Third one for that IoT data encryption. Of the user and prevent the IoT data bridges. So encrypt the data and rest in the transit between the IoT devices and backend system. So by using that standard cryptographic algorithm, we have to maintain fully encrypted keys lifecycle management process to boost overall the security of the user and data and privacy. This is the technique we have to use it with that. We have to secure of IoT encryption. Excuse me. The fourth category of use of IoT PKI security methods. So we have to ensure a security connection between the IoT devices and the app. Use of IoT public key infrastructures, that is called as PKI. We have used in the term. So X.509, that is called as digital certificate, cryptographic key or life scale capabilities including public or private key generations, distributions, management. These are the techniques we have to method from the PKI model. So IoT security analysis. So it's solutions that are capable to detect IoT specific attack and intruders. So which can't be identify the traditional network security like the rivals like we have to maintain. Next one from the IoT IoT API security methods. IoT API security methods not only to protect the integrity of the data movement between the IoT devices. So we have to maintain with the backend system and applications using REST method. So here we have to ensure with only authorized devices, developers, and apps are communicating with API, or we have to detecting potential threat against the API method. So next one from the test the IoT hardware. So it is a place we have to check with the framework, testing framework, in place to ensure the security of IoT hardware. So we have to testing of IoT devices range, capacity, latency. So the chip manufacturers of IoT devices also they have to check with the reinforcement of the processor for more security and less power consumption without making them too expensive, because we have to low cost of devices, so we have to cost is very important parameters. And then IoT device manufacturers need to do the broad testing for all third-party components and modules that are using the IoT devices to ensure the proper functionality of the IoT applications. Then develop secure IoT apps. So it is the current IoT technology for creating the app. So the developers of the IoT applications must emphasize the security aspect of their IoT solutions. By strictly they have to implementing or we have to security technologies like digital certificates, or maybe on PKE model, or maybe on encryption techniques, like say we have to firewalls or anti detection system IDS. That is a category we have to maintain. So developing the IoT application, the developers must complete the research on the security of the IoT application and try to get perfect balance between the user interface and security. Because already I pointed out as a security and usability, there are two different parameters we have to balancing. So that is the thing we have to develop that secure IoT app. Then avoid launching of IoT devices in rush means we have to competitive world, we have to manufacture of IoT devices to launch their product in the market with the lowest price. So while doing that, don't pay that much of enough attention to provide the security updates and patches. So sometimes there are people are developing the software, they have to not updates in software, they are not they have to pay. So they have to this poses the serious threat to the security of the IoT devices in long run. So overcome this challenges, the manufacturers of IoT devices should avoid the launching their product without the proper planning for long-term support for the security of the IoT devices and applications. Then last one for that latest IoT security threats and pressures, we have to ensure the security of the IoT devices and applications. The device makers and the app developers must known of latest technology of IoT security threats. So because that emerging technology, so they have to hackers are coming, so that patch related files. Here the IoT app developers must be ready for security threats or proper exist plan to secure maximum data in the case of we have to secure. So here the IoT developers must also take the initiative. They have to developing team. They have to teach for IoT threats or security solutions. Then only they have to get that good solutions. So here I have to point out some of the solutions from that various person. They have to point it from the 5 different method, one from the authentication, another from the type of attack, security framework, lightweight encryption algorithm, hardware security support. These are that proposing the solutions. They have to check it, they have to verify it, they have to get in that good results. So the authentications, they are used with unique fingerprint to authorize such a type of devices. So the fingerprint in IoT may contain the features like physical state and locations. So the IoT devices got different fingerprint features. So due to working environment or maybe on transmissions of learning techniques. So it can be authenticate the devices with the different fingerprint features. So this technique can be category of two different, one from that two two different phases. One for that verify the packet sent by the single device. Next one for the second phase is to validate the credentials of the submitting devices. So here we are using with IGMM infinite Gaussian mixer model. It is used to generate the fingerprint for the every devices. So here validation is done by only from IGMM. So here how the performance working means, the expected that thing from that transmission of learning technique will be direct the change, the difference between the normal change or it may be an molecular one. That is the way they have to checking. The second technique for that authentication protocol. So authentication protocol is a key establishment of distributed IoT with a P-authenticate key. So that key is here two phases. One for the registration phases, which is used to cryptography. The first one is used to initiate the cryptography between the IoT devices and the user registering key. The second phase we have to authenticate the key is communication. So P-authenticate key provides the ability to authenticate the connection between the user and the sensor in the IoT devices directly and bring the access to its service and data. So this type of key, it may be on lightweighted and handle the high secure devices. Moreover, it may be on working. So the particular author may be on they have to develop and then test it. The third one for the SDN, that is called software defined networking model. So the idea is that the device is connected to the gateway, so which can access the central data. So each authorized devices should go through the gateway, then the controller could have the access the system. So here from that the message will move the three nodes, one from the device, another from gateway, another one from the controller. The first, the certificate will generate from the controller and send to the gateway. So then the devices will register the gateway. Finally, for each new devices in the system, authorized request will send to the gateway by other devices or to check. That is the way we have to checking with the authorization. So this result of this SDN method also they get, and also they have to avoid it from the replay attack or in the middle attack. This type of attack they have to reduce. Types of IoT, types of attack. Already I said that in the previous presentation itself, I point out. So security framework, because the types of attacks in that solution, they have to check with that hardware side channel. They have to maintain with that hardware, software, public key cryptography, wireless sensor networks, and then security approach of for off-chip memory based on microcomputer systems, and device-driven approach for the embedded security, and then new trends in personal recognition systems. Also, they have to work. They have to compare. So here's the second category from the security framework for IoT. So here the security framework that provided a secure system in smart infrastructures like smart building. So here the four different layers, one from that IoT node, another one from that IoT network services, then applications. So here it is used to identify the IoT node and the appropriate migrate mechanism. It may be on rather we have worked with the encrypted data with due to low power, low computation of power in IoT devices. So that type of thing we have to work. So second category from security framework for IoT, it's a reference model, that is IoT architecture reference model. So IoT ARM. So we have to frame up that the provided security with the privacy in IoT, which can be used with the smart building and smart homes. So this framework, it focuses authorization with IoT devices to secure the data. So this may be on depending on the key security expert to authenticate the devices. So it may be on controlling the local data as well as the all the services provided by the IoT devices. So here from that lightweight encryption algorithm, most lightweight encryption algorithm, first one for that DOS. So in that algorithm, we have to that algorithm will be divided into four groups, one from the working node, second one for that attacker, third for monitoring legitimate user node. So they have worked with that different method. So working on monitoring node, each working devices should differentiate between the authorized request and molecular one. So this can be detected if the sender sends the same request to several times. So that is the DOS attacks. So any request received from the attacker that will be a servlet with only the first time, then it will be blocked. So legitimate user node will be checked with the second. Sender send the responsible normal request at lower frequency. They have to check with that lower frequency node also. Then the next category of lightweight encryption algorithm, that is called as encryption query process algorithm in IoT. So this algorithm support the database query over the encryption technique. So this encryption database query process over encryption algorithm. So idea is to store the encryption data through the cloud database with an end-to-end system. So this encryption decryption will be happens client side only. So the process IoT will encrypt the data, then upload it to the cloud database. That will be stored in the information and accepted any query with encryption. It shows the result improvement time comparisons also is a good one. So next category from that SPE, that is a technique from that synthetic packet engine method. So algorithm to we have to hide that algorithm. So this algorithm is a good. We have to, because the hackers we have to getting immediately, because they have to check with that network traffic. They have to learn the time frame from weekly, monthly, because we enter data. We have to monitor the entire data. So based on the real-time data, we are going to checking from that average interval, mean or standard deviation we are taking. So based on that, we have to taking the traffic data. So that data we have to monitor. So based on that data, we have to work with the traffic. We have to learn time by time. So real data we have to check also false alarm rate also we have to check. So this is the method we have to drop it of SPA method. So next, lightweight encryption and other taking from that, we have used it from that digital signatures, and then Diffie-Hellman, and then Diffie-Hellman we have to measure it as a stateful. We have to reduce the sum of the point here from that point of what we call them, the ciphertext. They have two different method we have to encrypt it, one from the data encryption, another one for the key encryptions. So the ciphertext is transmitted with separately in that ciphertext data transfer, so without being detected by the attackers. So this may be an IBA, that is called as identity based encryption techniques. So that may be an identity of string. We have to publicly we have to check. So we have to use it with the digital certificates. This is the lightweight encryption algorithm. So another category we can call as a hardware security support for the IoT. So here we are using with TEE, trusted execution environment, and also TNC, trusted network connection, HROT, that is a hardware root of trust. So here security needs, we have to privacy, integrity, reliability. So we have to move on the structure of IoT with the CPS system. So CPS, we are using the CPS system. We have different layers: application network layer, and then we have to for the perception layer. So at the time, security standardization of IoT with the CPS, we have to use it with wireless security with the different layers. So you using the hardware technique of IoT, we have to check with of TEE and then TNE, and also HROT, hardware based models we have to check. So based on that, we have to some new method of SOC of FGBA method we have to detect of particular improvement. So this may be an hardware based security concept, maybe on cost acceptable cost, because normally the security algorithm, if you are working with the software based, we have to cost is reduced, but in the hardware based technique we have to invest much more of cost. But the CPS with the IoT device secure system will be an accepted cost only. So the thing, these are that proposed solution reference papers. So what we have to say that method. So the thing before I conclude that the devices we are reading so much of data. So CPU have the size of a processor size. It may be only small. So we have used it with we can't able to complex. We can't able to do that method. So previous RSA, DES, AES algorithm is a standard encryption algorithm. But algorithm is suitable for that normal IoT devices, because the IoT devices you have the using the devices are to battery. So on the battery, we are using the new lightweight encryption algorithm. That's only these are the reference purpose. There is a lightweight encryption algorithms or lightweight encryption algorithm we have to use. So these are things we have to use. Thank you all. Thank you for any queries. Thank you.
Thank you, sir.
Thank you.
Participants, if you have any queries, person, or may you utilize the chat box.
Anita Rani is lifting the meeting.
I think there is no queries about from the participants,
Okay.
sir.
Okay, thank you all. But before that, I conclude that security have the I listed the topmost security. These are the papers I refer. So using that encryption technique is the best way. We have to secure our data. Okay, that's all. Okay, thank you all. Any queries? I left.
Sir, another one, sir. Shall I give you any idea for the research oriented, sir? Some faculties are doing pursuing the research, sir. So
Sure,
from
sir.
your point of view, you can give some ideas or
Also, yeah,
for doing in IoT.
Yeah, of course, of course. In IoT, only security part only myself. In hardware based, I'm not sure about that. If you security have any clarification, you can call me at any time. No problem. Saravanan Kumar,
Any of your ideas, sir? How to get the papers or write the research papers to
yeah,
this IoT security?
these are all our reference papers. This you see there, you see, it's a current trend. I clearly point out. Yeah, we have more number of devices, more number of what we called more scope is there, because day by day the devices is increased. Definitely the problem also increases. So we have to give that right solutions. We have to even patent also we have to apply if you give the right solutions. That is the thing.
Okay, sir. Very much. Thank you, sir.
Thank you.
So thank you for a wonderful session, sir. They have explained very clearly.
With our management. Shall I start?
Thank you. Actually, management has provided the best opportunity to have you like a resource person for this type of recent topic in